I'm going to tell you a little about the this project I have been following. It's Flubot, Android banking Trojan, and I will tell a little how the threat actor is acting, and what are they doing, and what are the capabilities of the malware. First of all, you saw that fancy Accenture slide, but they paid me here, so I work for them. But my opinions might not be in line with my current employer or any previous employer. So all my comments and thinking are my own and not impacted by the employer. So my name is Juho Jauhiainen. I'm from Finland. I work as a lead investigator at Accenture, doing digital forensics and incident response mainly, some malware analysis as well. Before this, I was working for Finnish government, and that's where my journey with the Flubot started, and I have been tracking the malware since last summer. But what is Flubot in generally? It's Android banking Trojan. It's distributed through SMS. So usually the SMS tries to lure the victim to go to a drop site and download the APK and install it to their phones. The distribution is done through the compromised WordPress sites. So they have plenty of WordPress sites that they can use for this, and they have burned thousands or 10,000s of sites just to deliver these APKs to victim phones. It's continuously developed, so we are seeing a lot of new versions coming up, almost once in a month. I will talk later on a little bit about the versions and what has changed and when. And they are also reacting to the mitigation activities that, for example, teleoperators are doing. So if they are changing some ways how to block, for example, the SMS messages, they are going to implement a new feature which will likely bypass the mitigation the teleoperators have done. But yeah, here's a screenshot about from the drop site and also SMS we saw in Finland, and as you can see, they usually have a lot of typos and so on. So we thought that no one will click this. Well, we were wrong, because when the situation was the baddest, there was millions of SMS messages going around Finland per day. So if you think Finland has 5.5 million people living there, and millions of SMS messages were delivered in a day, everyone was getting those, and those were headlines in news that, did you get this kind of SMS? Don't click the message and download the APK. But that was background of the okay, this not working. Nice. So that's the background of the Flubot. So as I told you, it's delivered through the SMS spraying. So infected phone sends a message to victim. If the victim clicks the link, they will go to the drop site, and the drop site actually knows from the given URI that who is clicking the message. So in some cases we have seen the drop site showing off the phone number where the SMS was actually sent. So they are having database in their backend where they are matching all the links with the target victims. So a lot of features that are not that common for this kind of bulk malware. Then if the victim downloads the APK and sideloads it, installs it to their device, they get infected. And the first thing the Flubot is doing, it will check the public IP address of the device. So it uses these 4 services that reveal your public IP address, and it stores the information to the shared preferences so that it can use it later on, and of course update it if the victim IP gets a new release and so on. And then it starts to communicate with the C2. And since version 4.9 of the Flubot, it has used DNS over HTTPS. So all the communication goes through the this cloud DNS providers like Google, Cloudflare, and also Alibaba. And they actually used this next DNS as well, but it was the only provider who started blocking Flubot C2. So then they dropped the support for the next DNS pretty fast and moved to use these 3. And we have been in Finland, in my previous job, I have been in contact with all of them, and they are not interested to touch their DNS over HTTPS because it's a whole thing, privacy and stuff. So we are not blocking even Flubot requests or any other malware there as well. So if any one of you are working for the companies, please do something. And then it starts to spray the SMS messages if the campaign is active in the current country where the phone is. So it will check the. I will talk later about how it checks the device info. But if the campaign is not active in the country where the infected phone is, it will not start sending those messages. It will just stay hidden on the phone and wait that they activate the campaign in that specific country again. I had actually made this presentation already, and I think on Wednesday evening, I saw a tweet from this user, Jake J. Cybersec, that he was able to dump the source code of the drop site. So I had to take a look at it. Actually, I flew here yesterday morning, so I analyzed the PHP in the airplane. And saw that it reveals one address from the back end, and I will get later back to this domain shown there, the smurfetta.russia, and and I will discuss a little about the infra and where it's hosted, but. If you are interested about the index.php, which was dumped by this Twitter user, it's pretty good Twitter thread about what is concluded in the code and what it does. So go and take a look as well. It's you can find the sample from VirusTotal. But yeah, a little bit about the time frame. So as I told last summer, I got involved with this case in Finland. It was the version 4.5, which started spreading in Finland, and that version was actually still using the legacy connection, so it directly connected to the C2 instead of using the DNS over HTTPS. So it was kind of easy to block. We just generated lists of these domains. It's using DGA, so domain generation algorithm. So we generated the list. And blocked all the teleoperators blocked these addresses in Finland, so they couldn't do anything. And we were like, yes, we won. And then a few months went by, and we saw new samples using DNS over HTTPS, and we couldn't do anything. So yeah, and since then they have released a lot of new versions. So they are going from static structure to more like things that they can update on the fly. For example, the DGA seeds, so they can generate different kind of list of those C2 domains, and also it makes us researchers' life a little bit harder because the Cs are not hard coded to the malware and they need to be downloaded from the C2. So a little bit more work for people who are analyzing the malware. And last month actually, I think it was end of February, the newest version 5.5 was released. Well, I found it using some retro hunts on the VirusTotal and checked that that's the newest version. Analyzing APKs is kind of easy because you can just decompile the package and read the Java. But of course, mobile malware are using packing as well as the like regular Windows and Linux malware are doing. So Flubot use it to use APK Protector, which is like known tool for APK packing. But they changed to this kind of customized encryption in I think it was version 4.9 where they introduced it, and it's first they have like multiple layers of obfuscation and encryption. So first layer is like a simple string obfuscation, and then there's an archive hidden into the resources, and then that is actually when you decompress it's an encrypted payload, and if you decrypt the payload, it will become an archive, and the archive will have the real classes.dex inside of it, and if you decompress that one, it's and see the source code, it's still obfuscated. So there is like a lot of places where they are trying to hide the real truth of the source code, but I think this kind of stuff is fun, and hope that they are implementing new features, so it will get a little bit harder to decrypt. But so as I told, they changed the way of packing between the June and November last year, and I think they will this year bring more features to that as well. So we will see and wait. So if we take a closer look how the packing is done. So first of all, AndroidManifest is a good place to start and see what the application is doing. So it's basically a list what services and listeners and so on are started when the application is installed and started. So the first thing we can see that there is this main function inside of the mobile QQ named package, but you cannot find the source code there, so it's packing. And if you go one line above, you can see that there is this crazy games package, which includes probably the code for the packing. Next slide is a little bit busy, but it's the function where the file I mentioned, the archive, where it's stored and how it like loads it from there, and then decompresses it. So the path for this specific sample is shown there. So there is assets and then blah, 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 blah. So and that is the actual file containing the source code for the malware. And then we can see that there is actually a decryption function which uses a static password from the sample. Of course, it's a little bit obfuscated as well. It's these Chinese letters, and if you deobfuscate that one, it will become a clear text string, and that actually means something. I think they are funny as well, because they're using like something that means something in Chinese, and also there was, I think it was the first sample I saw, it was like evil in English, the Chinese text. So yeah, I think this is like like Easter eggs there hiding there, and I kind of like it. Then if you look at the actual decryption function, you can see that most of it is like rubbish, and there is only like few parts which are used for the actual decryption of the classes.dex. And when I put it to this slide, it looks easy, but it actually took some time to figure out how to unpack the package. And when I had done it, I wrote a little Python spaghetti code, and then ran it, and got the actual DEX file. So now we can actually start analyzing the malware. And this took like in the last year it took like 1 week of work days to figure out how it's done. So when the user installs the malware, it actually requires a lot of like permissions from the user. So it prompts the user if it can use the layouts in Android, which means that basically the malware can show anything, can intercept anything, can do anything with the phone. So it's like super dangerous thing to give any app this kind of access. And of course it's telling that the instructions how the user can actually disable limitations which Android nowadays builds with ships with. They are helping the victims to make their phone more unsecure. And during the installation, it actually checks the after the user gives the rights, it will check the public IP address and a lot of other stuff, which is going to be stored into the shared preferences of the application. And this is because it wants to store this kind of configurations like for longer times, and many of the Flubot functions are using the same values, so it uses shared preferences for that. And one of the things is bot ID. So this is the way the attacker actually can specify which device is calling back to the C2. And this is unique for phones. So a lot of interesting information. And for example, as I said, they have been implementing these new features so that they can update like dynamically those DOH servers and C2 servers and so on. So there is one shared preference for new DNS over HTTPS servers. So as I told, they are using the Google, Alibaba, and Cloudflare, so they can basically update their whatever they like. And also, if someone, for example, starts to blocking them, they can implement new server there and ensure that they can continue operating. And also the custom seed, which is used for the DGA. So when they created a list of C2 domains, they are using hard-coded seed, which has been 1945 in many of the samples. But of course they have this feature so that they can update it dynamically. Flubot has a lot of like hard-coded commands. It's which are used for C2 traffic. So before starting the C2 communication, it uses this pre-ping command where it basically connects, tries to connect over 2,000 C2s and checks which one of them is alive. And because there is a lot of like the DGA generates over 2,000 domains, and because of this they are like really agile, moving from one location to another. So this is why tracking Flubot, for example, the C2 infra might change every day. I will have a few photos about the current infra from yesterday, and probably it's different already today. So old info. And it also has the ping comment, which is actually the keep alive. So that's the basic home calling command. And the ping command also has the version number. So it will tell the attackers which C2 version, which Flubot version is in use. So that is the place where you can actually track which version of the Flubot is the current one. And they are updating the minor versions kind of often. It also has possibility to send SMS content, so it's intercepting SMS messages and delivering all of the contents to the attacker. So basically, bypassing SMS-based MFA is really easy if your phone is infected with Flubot. Also, it will not show the contents to the victim. So if someone is trying to, for example, send a message to them that your phone is infected, it will not reach the victim, but it will go to the actual attacker. And one of the Finnish teleoperators used SMS to send messages to their customers if they were infected with Flubot, and they were wondering why nothing happens, and this was the reason, and they were surprised that they need actually to send letters because they couldn't call them. The calls were blocked as well. So, and and then there's this DGA. So there is hard-coded list of TLDs which the Flubot is using. I think this is just a lure because previously they were using 3D TLDs. The list was had only three of them: the Russian, Soviet Union, and China. And now they are using. Yes, Soviet Union has their own TLD. I'm not sure why, but And but now they're using a big list of different TLDs, but the the active C2s are usually in .ru, so in Russia country domain. And it will generate 2,500 domains and try to contact them afterwards. So it creates 25 threads that test those generated domains. So the amount of traffic going out of the phone when the Flubot is installed is enormous. So basically, if I have my home setup, I have Burpsoid connect proxying all of the requests coming out from the test phone, and when I do that, it's 10,000 requests pop up to the Burp. So it's very lousy. And for the actual seed, which is used for the random in Java, it uses the hard-coded seed. It's the 1945, and also it uses the current month and current year in the generation algorithm. So basically, every month you have to regenerate the list of the of the Flubot C2s if you are willing to track those. And as you can guess, I am actually tracking those. So this is example of list which kind of domains the algorithm generates. So here is the list of February domains and also March domains, and in a few weeks I have to generate the April domains as well. And if we look at the current C2 infra and where it's hosted, so basically as it's using the DNS over HTTPS, the requests are not going to that actual domain, but to the name server of that domain. So in this slide, you can see the C2 domain, the name server it's using, and then the IP address of that name server, and then also the AS number of the hosting company. And this is actually from a few days ago. So we can see that there was not that many active domains at the moment, and most of them were sinkholes. But if you are using DGA, I'm not sure if sinkholing is does anything. Of course, you can track the amount of infected devices using that, but sinkholing is not a solution to tackle the Flubot problem. This one is actually the real deal. This is the active C2, or was the active C2 few days ago. And if we look at the AS number, it's this. I recall which country it was, but some African country which gives routing services for everyone, and it's called Elite, Elite team, and they have this funny thing in their who is information that, for example, okay, seems good, but they have this nice information about the Netcraft, which is a service provider that takes. They offer services where they take down what's going on. All right. How it works. Yeah, but they offer services where they take down, for example, C2s or phishing sites and so on. So they send a lot of takedown requests. So they are claiming that these Netcraft guys are spammers, so they are not answering their requests, and this already tells something about the AS and what's hosted there. So that's red flag of cybersecurity. If anything goes to that AS, it's probably bad. So as I said, they're updating it constantly. So this is from yesterday, and as you can see, there is not that much domains anymore, but we can see 2 active domains. So they are here, these 2, and they are hosted in different AS, and this is Russian AS, and it's called Horizon. So it's we have seen that in many different malwares using the same AS. So probably that's the real AS they are using for the C2 infra. And if you go to these C2 domains by browser, it's nothing, but you can see that their IP addresses are as well in the same AS. So they are. I'm not going to touch the table anymore. Yeah, but they are hosted in Russia as well. And before they moved to the DNS over HTTPS, they were using these legacy connections, direct sockets to these addresses, and then their site had this kind of propaganda there. So I'm not going to try to say that, but it's it was feds fuck off, and hope you can have good spirit and something like that. So and this is the old president of Russia, the Medvedev, how do you say? I'm not sure, but the guy before Putin. But yeah, and if you remember this one. Can you guess the AS? Yes, it's the same one. So it's the Horizon from Russia, and I know that there has been a lot of takedown requests to these domains, but the response haven't been that good. So we are still working on it, and if you are working for that AS, please tell your company to stop. So how does this C2 tunneling work? So as I said, it's using all the C2 traffic goes through DNS over HTTPS. So I'm not going to read out those load, but it basically makes a blob of data, and then it's encrypted and then encoded with base 32. And the actual like the command and response is encrypted with ARC4, and the key for that is actually generated when the Flubot is installed on it's generated for each and every command, so it changes on every command. So if you are figuring out one of the RC4 keys, you can only decrypt that session, and in the first ping, it will deliver the client will deliver the RC4 key to the server, the C2 server, and first it encrypts it with the RSA, and it has hard-coded RSA public key in the sample, and it has been the same the whole time. And then the C2 will answer if it can decrypt the payload. So I have, for example, I have been creating this kind of emulator, so I do not have always run the sample. I can just use my Python to interact with the C2, and I had a lot of problems at the first with the data formatting with the C2, so it didn't answer me anything, and now it's working partly. So the actual request looks like this. So there is this DNS over HTTPS host, and then there is this session ID, then which number the request is. So it's a SQL number, and then if it's sending data or receiving next. So when the last request has 1 here, and the others are sent with 0. And then there is this blob, and then of course the C2 host. And the request type is always TXT, so it's always requesting same type of data from the C2. So what does the C2 answer to the client? So the client has multiple different capabilities which it can do. I will mention few of them. So I think the worst one is the socks. So attacker can actually have direct connection to phone and do whatever they like there. So it's basically a backdoor. I haven't seen that being used, and I don't know if it has been used, but there's a feature for that. Then, of course, the upload function, so it steals a lot of data from the phone, all contacts, SMS messages, and so on. So it's like a nightmare for the victim that they will lose all of their information that they are storing in the phone. And then, of course, it has these layers, or they call them injects. So basically layers that can be used for phishing and showing any content to the victim they want, and for example collect bank details or what else, any credentials. They targeted actually Gmail as well, so they had a layer for Gmail. This actually works in a way that the client sends list of all installed packages to the C2, and C2 answers which packages it wants to monitor for credentials. So to get the list, what they are targeting, you have to generate the list of all applications available in Google Store and send it to the C2, and then the C2 will tell you which ones they are targeting. And and then there's this interesting thing as well. As I said, that they are hosting the Infra in Russia, but they are also avoiding Russian and other countries' victims. So they have whitelisted a lot of languages, system languages. So the installation checks which language the phone is using, and then the installation will not continue if one of the mentioned countries is used for languages is used in the phone. And if we put these countries to map, it looks like this. And by the way, I'm not attributing anything. I'm just saying that they are not targeting these countries. These countries where these languages are spoken. So which countries they are targeting? A lot of like Western countries. I also know that there has been campaigns in Australia and New Zealand, and also in Ireland. But I haven't seen samples by myself that use, for example, these country codes of these countries. So basically, these are the countries they are focusing right now, and probably I think this is planned that these countries are the targets, and those informations are hard coded in the code, and they haven't changed that much. So probably we will see new campaigns, Flubot campaigns in the future in these countries as well. Their goal is financial, or at least it looks like it's financial. So they are creating these phishing overlays, and at the moment they are targeting, in Finland they targeted Coinbase and Binance cryptocurrency wallets, and also Gmail. And I think in UK, for example, they were targeting bank applications. So it looks like it's a financial motivated group, and they are actually delivering those phishing overlays as HTML. So I did download the injects they are giving, and by looking at the code, I saw some Russian comments. So they were telling. I used Google Translate to check what those comments were, and there was like in the CSS file there was like background and then comment that this is background, like in Russia. So it makes me feel that these are not that good in English, the persons who are doing at least the overlays. So what's my conclusion? Threat actor. This is not attribution, but they are hosting their C2 in Russia. They inject HTML code, which is commented with Russia. They old Infra shared Russian propaganda, and they do not inject systems that use Cyrillic alphabets. And their motivation is probably financial, but my question is why they are using so much RD for this. They are using like a lot of resources to update the software. Also, hosting the hosting infra is kind of large, and of course the drop sites they are burning like super fast those compromised WordPresses. So they are financial. I think they are financially motivated, but why they are spending so much resources on this? Because I think you could actually do this with less resources as well. And what can the defenders do? The providers of the DOH servers, they should do something, I think, because if before Flubot, I didn't see that much. I hadn't seen that much like malware samples that use DNS over HTTPS. And now it looks like I think Cobalt Strike has some kind of feature that you can actually implement the DOH there as well. So when we go to the world where all the malwares are using Google or other services for their C2 channel, it will get hard as a defender to defend your company or organization network, because you have no visibility and you cannot actually block those as well. So it's getting hard. So I hope that these DNS over HTTPS providers should pay more attention what they are delivering to their network. And not the best way, but the best available method is to use SMS and MMS firewalls. The teleoperators should use them, so they should filter the traffic so that these these spreading messages won't go through. Of course, it's hard because they're changing the layout in the messages a lot, and a lot of like legit services use also SMS. So it's hard to like filter the right traffic away. But yeah, that's the best way how to block this if this comes to your country, or if you are working as in a teleoperator. All right, but here are some resources. So if someone wants to take a look at those samples I mentioned and so on, so here's hashes, and you can actually download them from VirusTotal, and also there are a few good reads about the Flubot as well available online. So if you're interested, take a look at those. Thank you very much. Do we have time for questions?
2 minutes.
All right, 2 minutes.
2 minutes for questions, guys. Hey, great presentation, by the way. Would you know any what kind of mitigation for an end user to defend against Flubot? Is there any current mitigation out?
Do not use Android. That's like
okay.
But you know, this I do not understand that why Android side loading is so easy, because these are not hosted in the Play Store. These applications, they are side loaded. So I'm not sure why, for example, my mother should ever have a possibility to side load software. So I do not understand that, but that's like the best way to like mitigate it. Do not click links and download stuff.
Okay, thank you.
Yeah, great presentation.
Thank you very much.
I'm curious, you mentioned your emulator, and you also mentioned target countries, but I might have missed it, but is the check for like geolocation early on, and does it influence your emulator in terms of like, I know you said it was partially working, kind of having issues, but I'm curious,
Yeah, well, they are checking the system language, and they are getting the public IP, and it's based on the public IP if they are activating the SMS campaign on the phone or not. So, for example, if I run the sample now from Finnish IP, the connection is made, but I will not get any commands from the C2. Just okay. Like it's working, but it's not giving any comments. And if I change it, for example, to UK, and if the campaign is there active, I will like instantly start getting comments from the C2.
And the second one is you didn't really touch on it, but you mentioned like hooks kind of true. Obviously, probably the end goal is to hook web browser to grab banking information. Have you looked into like the webhooks, or is it webhooks that they're using for like a browser? You mentioned Gmail as well, but
yeah. So I haven't like done anything like doing fake credentials delivered there and looking what they're doing, but they are doing like the layer. I mentioned the Gmail. So basically, if you're using Gmail application, you will open it and the layer will just pop up, and the user won't see it. It's just a like normal Gmail login page, and then they will fill the creds, and then they will leave to the C2.
Yeah, from my experience, I know I see like it would be the Gmail will pop up, but it would be an API being called with Gmail being put in as a parameter, and that would be the hook. And
yeah, but they will deliver the
their own version of Gmail. Yeah, that would pop up.
Yeah.
Interesting.
Yeah,
cool.
Yeah.
You listed the commands. Were they actually in English, or did you give it English names for?
They are in English, so yeah, they are. The list is in English. It's a case table, and it's there.
Yeah, you mentioned Cobalt Strike a few slides back. Have you seen much Cobalt Strike pop up for this kind of attack, or
no? I don't. I do not think that Cobalt Strike supports ARM. The ARM devices. So I'm sure. Probably ARM, yes, but Android devices.
Thank you.
Yeah. All right. Thanks.
Yeah.
Okay, thanks very much, guys.